Yes, I wanted you to imagine again that you're in an experiment, and in this time in the experiment you see something that you didn't saw before. And it's the fact that the magnitudes change different than how you know with directly proportional magnitudes. If you remember, with directly proportional magnitudes, when one increases, the other increases, following a common rate. And here you can see that when one increases, the other decreases. So we're going to see how to identify when you have this relation between two magnitudes and how you can interpret it using inversely proportional magnitudes. So let's imagine that in this case you're a scientist who measures wavelength and frequency. And you can see that for the first two values you have these results in which at first sight you only see that when one increases the other decreases, but you cannot see some relation. Then you start thinking of what you can do to see something in common between these variables, and find out that if you multiply the wavelength times the frequency, you have something interesting. 2.5 times 1.4 gets you 3.5. Okay, we're going to set the units, sorry. So 2.5 meters, 1.4 hertz gets you meters times hertz. And here you multiply 5 times 0.7, 5.0 times 0.7 meters hertz, and you got 3.5 meters hertz. So as you could see, we have something interesting here. That is, if you multiply both magnitudes, you're gonna have the same result. And if you have the same result, it means that when one increases, the other should decrease, because if one increases, to keep the common product, the other should decrease. This is what we call inversely proportional magnitudes. So you can understand that two magnitudes are inversely proportional when one increases and the other decreases using the same proportion, keeping the common product. By keeping the common product, you can see how is the new variable. And this is excellent because then you can predict what's going to happen to the variable. If you need to know 7.5, you need to know what happened for 7.5. So you just need to find out a number times 7.5 that gets you 3.5. Okay, but I'm not writing the units, but you will understand that we're using the units. And here, so you can say that the frequency is going to be only our number over 7.5. Okay, I'm not going to use calculator. I'm going to do it quickly here. 35 over 75. I can have the fifth part, that would be 7. And the fifth part of 75, it will be 150. 7 over 50. Okay, so I'm going to put here 7 over 50. And then you can write, okay, but what happened if it's 10? So if it's 10, remember, times the frequency. And look at that, instead of always writing 10 times frequency equals 3.5, we can say that this relation, it's going to be always our constant 3.5 dividing the number, in this case, I'm going to write wavelength, it's going to give you the frequency. Okay, in this case 3.5 divided 10, so it's 0.35. And this is how you can predict information using inversely proportional magnitudes. You see that you can just find the common product and then divide by your common product, divide your common product by the numbers of the magnitude to predict the other. This is something that you can do here. Just as this is a constant for all our work, this is what we call the constant of proportionality. Look at that in this case, maybe you can say, oh, but how is the proportion here? Look at that in this case, the proportion, it's different than if you have directly proportional because it's not common rates. In this case, the proportion is keeping the common product. It's like if you apply a cross product for a proportion. If you remember cross product from the other videos, you will see that this is kind of a cross product. So it's already done the proportion by a cross product. This is why we call it directly inversely proportional. And finally, I suggest you take these values, do the graph, plot it on a Cartesian plane to see how it's going to look. If you graph an inversely proportional magnitudes, in this case our frequency in hertz and our wavelength, you're gonna have this kind of graph that we call a hyperbola. So just remember, if you have inversely proportional magnitudes, first keep the common product. This is what you need for inversely proportional magnitudes. Second, if you have inversely proportional magnitudes, you can predict the value by taking your constant of proportionality, your common product, divided by the variable that you're using. And third, when you graph inversely proportional magnitudes, you should have a graph that we call hyperbola. And I hope that you have an excellent day and see you in the next video. Bye bye.